Assalamualaikum warahmatullahi wabarakatuh. Well, welcome to Petrochemical class. On this great opportunity, let me, Muhammad Muzadi, and my friend Tasya Larasati, UFND, proudly present the manufacture of synthetic gas, which we then abbreviate as syngas. So we decided into two outlines. The first outline will be explained by my friend Tasya, and sub them the story of syngas. What is syngas and physical and chemical properties of syngas? While the second outline will be explained by me with two subterm production of syngas and the uses of syngas. Okay, we'll go to the first subterm with history of syngas. Tasya, time is yours.
Okay, thank you, Muzadi. The first history of syngas. To this day, however, methanol and ammonia are still produced from syngas using essentially the same process originally developed and apart from hydrogen production constitute the major uses of syngas. In 1780, Felix Fontana discovered that combustible gas develops if water vapor is passed over carbon at temperature over 500 degrees Celsius. This carbon monoxide and hydrogen containing gas was called water gas and mainly used for lighting purposes in the 19th century. As of the beginning of the 20th century, hydrogen or carbon monoxide mixtures were used for synthesis of hydrocarbons and then, as a consequence, also called synthesis gas. Okay, next. Haber and Bosch discovered the synthesis of ammonia from hydrogen and nitrogen in 1910, and the first industrial ammonia synthesis plant was commissioned in 1913. The production of liquid hydrocarbons and oxygenates from syngas conversion over iron catalyst was discovered in 1923 by Fisker and Krebs. Much of the syngas conversion process were being developed in Germany during the First and Second World Wars at a time when natural research were becoming scarce and alternative routes for hydrogen production, ammonia synthesis, and transportation fuels were a necessity. In 1943 or 1944, this was applied for large-scale production of artificial fuels from synthesis gas in Germany. Okay, next. What is syngas? In its simple form, syngas, also called producer gas, town gas, blue water gas, and synthesis gas, is composed of carbon monoxide or CO and hydrogen or H2. The name comes from its use. Syngas is combustible and often used as a fuel of internal combustion engines. It has less than half the energy density of natural gas. Syngas can be produced from any hydrocarbon feedstock, including natural gas, naphtha, residual oil, petroleum coke, and coal. The lowest cost routes from syngas production, however, are based on natural gas, the cheapest option. And next, okay, the choice of technology for syngas production also depends on the scale of the synthesis operation. Syngas production from solid fuels can require an ever greater capital investment with the addition of feedstock handling and more complex syngas purification operations. The syngas composition, most importantly the H2 ratio, varies as a function of production technology and feedstock. Okay, and then the next is physical and chemical properties. The first, hydrogen or H2, physical properties. With only one proton and one electron, hydrogen is the lightest of all chemical elements. At ambient temperature, molecular hydrogen, H2, is a colorless and odorless gas. hydrogen condenses to a colorless liquid. It freezes at minus 259.15 degrees Celsius. H2 is 14 times lighter than air. Okay, you can see the table about value, unit, and property of the hydrogen or H2. And next, this is continued from the previous table. You can see and read the table. Okay, next, and then chemical properties about hydrogen or H2. In air, H2 combines to water with a healthy visible, weakly bluish flame. Hydrogen combines with almost any other element. Metal compounds with negatively charged hydrogen are called metal hydrates. Example: CaH2, NaH, and LiH. Hydrogen has a reducing effect on a lot of metal oxides when heated. Thus CuO with H2, for example, reacts to Cu and H2O. Hydrogen has a reducing effect on a lot of metal oxides when heated. And the next physical and chemical properties about carbon monoxide or CO. Physical properties. Carbon monoxide is colorless, odorless, and tasteless. It is highly toxic, poorly soluble in water. Solubility 23 ml divided liter at 20 degrees Celsius and 1 bar. And you can see the table about value, unit, property, the carbon monoxide. And this is a continued from the previous table. You can see and read this table. And then the chemical properties about carbon monoxide. Together with air, carbon monoxide forms explosive mixtures in the concentration range of a CO volume fraction of 10.9 until 76%. In engineering, it is obtained by separation from synthesis gas. The reason for its toxicity is its property to displace the oxygen from the hemoglobin complex of blood. Since the affinity of hemoglobin Hb to CO is about 300 times higher than to O2, the hemoglobin of a heavy smoker of cigarettes can reach a CO saturation of up to 15% in the course of a day. And the next material will be explained by Muzadi.
Okay, thank you, Tasya. Well, now we're going to show the production of synthetic gas. In this presentation, there are four methods to product the synthetic gas. The first is steam reforming. The second is autothermal reforming. The third is partial partial oxidation, and the last is cold gasification. What about their explanation? So check this out. The first method is stream reforming. Steam reforming, or also known as steam methane reforming or SMR, is a method for producing syngas by reacting of hydrocarbon. Usually use methane with water. Commonly, natural gas is the feedstock. The main purpose of this technology is production of hydrogen. The reaction is represented by this equilibrium. You can see in the slide. So methane or C4 plus water H2O will product carbon monoxide CO and hydrogen gas H2. This reaction is strongly endothermic. delta H 206 kilojoule per mole. This route is used when natural gas is abundant and inexpensive, and it's commonly used in Saudi Arabia and USA. For the processing of steam reforming, you can see on the corner of the slide. The second method is autothermal reforming or ATR. ATR using oxygen and carbon dioxide or steam in the reaction with methane to form syngas. The reaction takes place in a single chamber where the methane is partially oxidized. The reaction is exothermic due to the oxidation. The first equilibrium you can see in the slide. The reaction can be described in the following equation using carbon dioxide. So methane plus oxygen plus carbon dioxide product hydrogen gas, carbon monoxide, and water as well. And the second equation is using steam with methane plus oxygen plus water, product hydrogen gas and carbon monoxide. You can see in the slide for the clearly equation. The main difference between SMR and ATR is that SMR only use air for combustion as a heat source to create steam, while ATR use purified oxygen. So it, the differences between the SMR and ATR is in the gas use. The third method is partial oxidation. Partial oxidation or POX is a chemical reaction that occurs when a mixture of a hydrocarbon feedstock and a stoichiometric amount of pure oxygen are reacted together. The hydrocarbon feedstock is fed into the POX reactor where the carbon in the feedstock is reacted with oxygen in the exothermic reaction forming carbon monoxide. The equation is C carbon plus oxygen kedua product carbon monoxide or CO. Typically, or a portion of the carbon monoxide then flow to a water safe reactor where the carbon monoxide react with steam, forming a mixture of carbon monoxide and hydrogen. There are two primary types of POX system. The first is thermal POX or TPOX, which occur at more than 2200 degrees Fahrenheit and it used with high sulfur feedstock. The second one is catalytic POX or CPOX, which use the low sulfur feedstock with a sulfur sensitive catalyst, allowing the reaction to occur in the lower temperature range of 1475 until 1650 degree Fahrenheit, while reduces energy consumption. So the advantage of the second primary type of POX is it reduces energy consumption. Okay, we go to the last method of production of um, syngas. Okay, next. Okay, the last method or the fourth method is coal gasification. Coal gasification is the process of producing syngas, which is a mixture consisting primarily of carbon monoxide, hydrogen, carbon dioxide, natural gas, and water vapor. So it from coal and water and or oxygen. The flow of syngas formation from this method or from coal gasification is shown in the flow that I have given in the slide. You can see the flow. It's the formation of coal gasification. Okay, now we're coming in the last step with the uses of syngas. There are four outline or the four mostly uses of syngas. The first is syngas can be used to produce a variety of chemical like ammonia and methanol. Number two, syngas itself can be used as a fuel in internal combustion engine. Number three, syngas is also used as an intermediate in producing synthetic petroleum for use as fuel or lubricant via the Fischer Tropsch process and previously the mobile ethanol to gasoline process. And the last, syngas can be used to produce organic molecules such as synthetic natural gas or SNG methane. But at this stage, the synthetic gas is mainly used for production of the product list in the table. For example, hydrogen and nitrogen is used for ammonia, carbon monoxide used for formic acid, hydrogen and carbon monoxide is used to acetic acid, and the mixture of hydrogen, carbon monoxide, and carbon dioxide is used for methanol. The two major chemicals based on synthetic gas that I have told you in the slide before are ammonia and methanol, which are each compound is a precursor for many other chemicals. The first is ammonia or NH3 and H3. The production of ammonia is a historical interest because it represents the first important application of thermodynamic to an industrial process. The ammonia synthetic reaction could be represented as the equation you can see in the slide. Nitrogen N2 plus hydrogen H2 product ammonia with delta H means 46.1 kilojoule per mole. The major and use of ammonia is the fertilizer field for the production of urea, ammonium nitrate, and ammonium phosphate, and also sulfate. And anhydrous ammonia could be directly applied to the soil as a fertilizer. Okay, next. The second uses is methanol. Methanol is produced by the catalytic reaction of carbon monoxide and hydrogen. The following reactions are representative for methanol synthesis. You can see in the slide. Carbon monoxide plus hydrogen gas product methanol with delta H minus 128 kilojoule per mole. And the second question, carbon dioxide plus hydrogen is also product methanol and water H2O. Methanol has many important uses as a chemical, fuel, and a building block. Approximately 50% of methanol production is oxidized to formaldehyde. As a methylating agent, it used with many organic acids to produce the methyl esters such as methyl acrylate, methyl methacrylate, methyl acetate, and methyl terephthalate. Methanol is also used to produce dimethyl carbonate and methyl dibutyl ester, an important gasoline additive. It also used to produce synthetic gasoline using a selective catalyst or MTG process. The flow of production of methanol. So in the slide, it's the forming of methanol by synthetic gas. Okay, we are on the last slide now. Thank you so much for your nice attention. If you want to ask something about our presentation, you can ask in the WhatsApp group. I think enough for our presentation. Many mistakes for us. I assume many